Hi everyone, welcome to MAM Pathshala, where the MAM is Metal Additive Manufacturing. I am Ananya. I am a PhD student at Indian Institute of Technology, IIT Delhi, India. In my last video, we have talked about the very basic of additive manufacturing or 3D printing, basically how it works. In this video, we are going to talk about different classifications of additive manufacturing. So we have learned that additive manufacturing is a layer by layer material deposition process. In this video, we are going to know what are the different methodologies of layer by layer material deposition process. So let's start our today's video. Based on ASTM standard, this additive manufacturing can be classified in 7 different technologies. What are those? So the first one is vat polymerization, material extrusion, binder jetting, material jetting, sheet lamination process, powder bed fusion, and directed energy deposition process. In these 7 different kinds of 3D printing, some of them are capable of printing metallic parts, but some of them are not capable of printing metallic parts. Some of them are capable of printing polymer based plastic material, some of them print resin based materials, etc. Previously, I thought to talk about only PBF and DED in this whole lecture series, but now I have decided to briefly explain all the different 7 types. After that, we'll get to know why we are only focusing on the PBF and DED process, that is powder bed fusion and directed energy deposition process for metal part printing. So let's start with vat polymerization. So this is a schematic of vat polymerization technique. In this technique, the material is used in liquid form. Especially the photoactive materials like resin are used as the depositing material in this process. So here we can see a vat full of resin is used where the light will be exposed through the nozzle. There is a white platform upon which the object will be formed. How? At first stage, so when this white platform will be just below the resin surface, over the white platform there will be one layer of resin. This light will be exposed through the nozzle over the platform. Now these photoactive materials have properties like they will be cured under the exposure of light. Cured means they will be solidified. Now they are in liquid form, but in the exposure of light they will be solidified. For light, we can use laser as well. So if we are exposing laser onto the platform, the resin which is present over this platform will be cured and will be solidified. So thus, one layer will be made over the platform. Now this platform will be lowered down by the amount of layer thickness or layer height. Again, the resin which is present inside the vat will come over the first layer which has been deposited over the platform. The light will be exposed again, or the laser light will be exposed again, and the next layer will be solidified. Like this manner, this white platform will be lowered down with each step, and with each step the resin will be cured and the whole object will be made according to the previously sent CAD model or the solid object that we are going to print. This is the process of vat polymerization. So we can think using this process we can't print metallic parts. So the next process is material extrusion. In this schematic we can see a wear kind of thing is coming, right? So in this process the material which is used is in wear form. Using this process we can print metallic part. You can note this. So using this roller kind of thing, the wares will be coiled in this roller. The material or the ware will come. It will pass through the setup. Now this setup will be not this type of opened setup. For the sake of understanding, I have made this schematic so that you can understand the things going on behind the setup. So the ware will come, it will pass through the feed roller. The working of this feed roller is to maintain a certain level of tension in the ware. So the ware will come, it will pass through the nozzle, and it will get deposited over the platform. This nozzle can move in Y direction or in X direction. But this material is coming in form of wear. So the wear will be very hard. So how it will be deposited and how the next layer will be fused with the previously deposited layer. This wear, when it will come out of the nozzle, it will be heated up and it will be in semi-solid form. You can think of the toothpaste. When we give pressure in the lower side, the toothpaste from the opening or from the nozzle, it come out. Similarly, here also from the nozzle, the wear will be heated up. So it will be in semi-solid form due to heating, and the semi-solid wear or the semi-solid material will come out from the nozzle and it will get deposited over the platform. This is how this process works. The next process is binder jetting. Using this process also, we can print metallic parts. You just remember this schematic of binder jetting, because when we will be studying about powder bed fusion, we'll be seeing similar kind of setup or similar kind of schematic basically. So in this binder jetting process, firstly, there is a two stage. One stage over which the object will be formed. In another stage, the material will be stored. In this process, the material will be used in powder form. This process is also capable of printing metallic parts. This stage will be at its lowermost position. This stage or this container will be full of powder that are going to be used for printing purpose. Now there is a stage which will be at the topmost position at the first, because over which the each layer of powder will be spreaded and it will form the object. How I am telling? First, this roller is used to carry a level of powder, a particular amount of powder, which will be spreaded over this platform. So at the first stage, this platform is at the uppermost position. This roller or powder roller will carry a certain level of powder and it will spread that amount of powder over the build plate uniformly. When it is done, this liquid binder will come through the nozzle. This binder will be sprayed over that powder. The working of the binder is just to fuse the powder particles together and make the object or make it solidified. So this whole process will take place in a heated chamber, because it will be needed for the powder particles to get heated up so that the binder can properly bind or fuse the powder particles all together. So this is the process. When one layer is done, this platform will be lowered down by one layer thickness. This roller will again carry some powder and spread it over the build platform, over the previously deposited part. This binder will again come and deposit over the powders. So this is the process. This is how with each step this building platform will lower down and the whole object will be made. The next process comes material jetting process. In this process, this material will be in liquid form. So we can see different kinds of materials in different form. They are used in different technologies. That's why I wanted to share all the different 7 kind of 3D printing methods, so that all can understand the various processes which are possible to deposit the material in layer by layer fashion. So in material jetting process, the polymer type of material are used. This is not capable of printing metal parts. The material will come with the nozzle. This build platform will be at uppermost position, the nozzle will be at lowermost position. The nozzle will deposit the part in a droplet form. The UV light is used for the curing purpose. Again, the droplet is depositing over the platform. So there we need something to cure the droplet so that the droplet will be solidified very soon. So UV light is used. Here one thing is written, support material. So in additive manufacturing, this support structure or support material is a very important term or important thing. In another video I'll be talking about this support structure and support material, because it's very important for the PBF and DED process also. You need to understand what is support structure, why it is needed, how it can be given, and everything. So let's keep it aside for now. So this is how the building platform will move in a downward direction with each step, with each layer thickness, and the whole process will be carried out, and the material will be, and the object will be formed. The next process is sheet lamination process. Using this process also, we can make metallic components. But this process is typically not used for making complex geometries. Due to its working principle, it is not capable of doing that. In this process, the material will be used in a sheet form. In a thin sheet of material will be used. It can be metallic or non-metallic. So the sheets will come using these rollers. These rollers are again used for the tension purpose, to make a uniform tension over the whole sheets. The sheet will come. The laser light will be exposed. Now this laser light is used to cut the sheet according to the desired shape and geometry of the object that we are going to print. So the laser will cut the material what is needed. Like if it is a sheet coming, it's a top view, suppose this sheet, and we are going to make a ball. So the laser will cut this sheet in a circular way. It will make a circle, and this roller will be moved from this direction to this direction over the sheet. Basically it will press the sheet so that the sheet will be get heated up, and it can fuse with the previously deposited sheet or with the next layer and the previous layer. So this is how, when one layer is done, this platform will move down by one step. Again next layer of sheet will come. The laser light will cut accordingly. The roller will move and will be heated up. It will get fused with each other. So this is the process. The next comes powder bed fusion. It's a very interesting process. As I said, now you can remember the schematic of binder jetting and PBF process is almost similar, right? In binder jetting, we were depositing the binder materials, and over the powder, the binders were deposited. The binder's work was to just fuse the powder particles all together so that a solid can form. In case of PBF, a laser light is used. This laser light will act as an energy source. So the laser light will come. It will scan the whole powder bed wherever the object is to be built. Means according to the shape, size and geometry of the object, the laser light will scan. It will move according to that path. The powders present at that part will get fused, get melted and fused together, and thus the solid object will be made. With each step or with each layer, this build platform will be lowered down with each layer thickness. The roller will come, bring some material, spread those out over the platform. Again the laser will be exposed, and this process will be repeated until the whole object is made. So this is the working principle of LPBF process. In case of LPBF, this roller type of things are called recoater, because we are coating the powder over the previously deposited material each time. And using LPBF process, metallic parts are printed. It's a very well-known process for metallic part printing. The next and the last one is directed energy deposition. This is a very well-known process for metallic part printing. Again, it is been used by industries like automobile, aerospace, biomedical, everywhere people are using DED. DED is also used for cladding purpose. What is cladding, we'll know about it in later on. And so in DED also, the material is used in a powder form. But you will see this DED process is very much different from the other type of additive manufacturing processes. A typically designed nozzle is used in this case, where the laser and the powder material will come simultaneously. These powders are coming and the laser is coming. Okay. This powder will get heated up when it will be in air because of this laser, and at the last these powders will meet at a certain point over this substrate first. Suppose this deposited layer is not here, so these powders will come and meet at this point over the substrate material or this building platform. This laser will also come and heat that point. So at that point, this laser will have its focus point. At the point of focus, the laser is having the highest energy density or the power density. So obviously all the powder particles present at that spot will get melted and deposited over the substrate. In this fashion, this nozzle will move from one direction to other direction, and the whole layer will be printed. When one layer is done, this nozzle will come back to its original position, and from that position it will move upward by one layer, and again another layer will be printed, and because of the heating of the laser, it will get fused with the previously deposited layer. So if I say this is the bottom view of the nozzle, so this nozzle is called coaxial nozzle because if it is a slot from which the laser is coming, here will be some circumferential slots. So these points are basically a small diametric slots through which the powder particles will come. So now you can think of the process. The powder particles will come through these circumferential slots, and through the central slot the laser will come. They both will interact over the substrate and the material will be deposited. So this was all about the 7 different kinds of additive manufacturing process. You can see all the processes are very much different from each other. All the processes are using different energy sources, different types of materials, all are independent with each other. So my main motive to shoot this video was to let you all know about all the different types of additive manufacturing. Next video onwards, we'll be talking about the LPBF and DED process only, and we'll know all aspects related to metal additive manufacturing. So this was all about today's video. If you have any query or suggestion, please drop it in my comment section. Thank you. Let's meet in my next video. Till then, happy printing.